Alright, so we have this problem of a ball being launched horizontally at 10 meters per second from the top of a 40-meter tall building, and a man stands at rest at 18 meters from the base of the building, and this guy is so slow that he has to have a 0.3 seconds of reaction time before he notices the ball moving. So he waits 0.3 seconds. So what it's asking is what's his acceleration in order to catch the ball. Okay. So there's multiple ways of calculating this, and this is how I do it. And while I show you this, just make sure that that these numbers over here in red are different for you, so you have to make sure that you use your numbers instead of my numbers, so that you get the question correct. Okay, so let's go ahead, let's get started. Okay, so if the ball is moving this way at 10 meters per second, but we're just gonna assume that the y velocity is 0 when it starts. So how do we calculate the time of how long it takes it to get to the ground? Let's see. Well, we can use the v naught. No, just kidding. Delta y. Delta y is well, v naught y is 0, so we're just gonna use 1/2 at squared. 1/2 at squared. And v naught y is negative 40 meters. So, and 1/2 a is negative 4.9 t squared. Let me keep the colors consistent. Okay, so t squared. So let's get our calculator and try to calculate for t. So we're just gonna divide negative 40 by negative 4.9 to get this number, and then we're just gonna square root this to see what we get. We get 2.857. So we get t equals 2.857 seconds. 857 seconds, just making sure. Okay. All right. So let's look at let's figure out how much the ball will move horizontally, like what the distance will be. Since we know the time, we can just calculate delta x. We can just calculate this using, well, acceleration is 0, so we're just gonna do the first part of the equation, which is v naught t. So it's gonna be 18 is equal to v naught is 10 meters per second times time is 2.857 seconds. So that times that. And so I mean, this is still unknown. My bad. This is still delta x. This is for the ball. So yeah. Let me change the color. So the ball would be this color. This color. Okay. Okay. Now get our calculator. We don't even need calculator for this. This is just well, you can use your calculator to figure it out, but I know what that times 10 is, so I'm just gonna say 2.2857 meters. Okay, I should have used this color, but yeah, that's how long, or that's how much this ball travels horizontally. So travels this way, 28.57 meters. Okay, now let's see how much that. So the ball goes like this. Okay, so let's see how much this man has to go. This man right here needs to go this distance, and that will be just this minus that. So let's just do that real quick. So that, I'm gonna multiply that by 10. times 10. Okay, so that minus 18. I multiplied it because now I have the right number, so minus 18. So that would be 10.57 meters. I could have just done that in my head, but whatever. Okay, so 10.57 meters. All right. Now we have this. Now we have how much this guy needs to move, but our catch is his reaction time here. How do we account for his reaction time? Well, let's see. Delta x is v naught, which is 0, and 1/2 a v naught is 0. V naught is 0. We're assuming that he starts at rest. So, well, it gives it in the question right here. Where is this? At rest. So, the 1/2 a t squared. Well, t right here has to be. Should it be plus or minus? Should it be plus or minus? Well, let's see. Let's try to figure this out. Well, his reaction time is 3 seconds. That means additional 3 seconds has to be added to t. So it's gonna have to t plus 0.3 seconds squared. Okay. Now let's plug in our numbers here. So 10.57 is equal to negative, or okay, I'm gonna try to figure out we're trying to figure out the acceleration here, so I'm just gonna plug it in. Okay, so 1/2. I'm just gonna plug in the numbers for right now. So t is how long the ball takes to fall, which is 2.857. 2.857 plus 0.3 squared. Okay, now let's isolate a and simplify. So how do we do that? Well, let's see. Okay. Well, we have 10.57, and we can get rid of 1/2 by multiplying this by 10.57 by 2. So 10.57 times 2, this thing right here, times 2. Okay, now we can divide this by 2.877 plus 0.3. Why is it 2.87? This should be 5, by the way. This should be 5. So that divided by 2.857 plus 0.3 squared. Okay, so we get the acceleration of 2.12. So acceleration equals 2.12 meters per second squared. And that's our answer.